Wasabi, you guys! Welcome to Integration B for Intermediates Part 10. In this section, we're gonna do a very hard to see technique. I just called it Undertow technique because you're going under a fraction, and you're just kind of you're factoring something out awkwardly. Let me go ahead and demonstrate that for you. So we have this very evil MIT integral. This is probably the best example I can show you. So the undertow technique, it's kind of like caveman substitution, like the one that I showed you where you have x to the power of n plus x, or whenever you have something like that, let's say like x cubed plus x, then the best thing to do is to like factor everything, x cubed, 1 plus x to the power of negative 2, whatever, and then u sub this. So undertow technique is the advanced version of caveman, pretty much, right? Caveman is just one form, just this, or some other forms that I showed you. But undertow technique is a lot trickier because it's a lot harder to see. So let's go ahead and dive right in to this integral here. This looks awkward, right? Because the derivative of this is 4x cubed plus 1. We have something else that's just disgusting. And if you try to form it like this, you'll end up getting, and then minus 2x cubed minus 2. Right? So here, you'll end up getting x cubed plus 1 in x cubed. Oh, wow. What? That actually works. Well, okay. Well, in that case, go ahead. Wow. I'm shocked. That actually works. So this is not a good example then. But usually I guess how MIT made this was to divide everything. Just keep dividing everything. When something looks awkward or very sus, divide x. Divide x. I know this looks wrong. This looks so wrong, but just bear with me. Okay, divide x again. Okay. Divide x again. What do you notice? That this is just ln of x squared plus 1 over x. That's all that is. The other one that we just came across was this, but it was simplified. So it was like x cubed plus 1. And then we came across something like this. It was something like that. But yeah, that's what that was. So this was their intention, and it gets ugly very quickly, and you'll start to understand why I find this very difficult to see. Oh God, this looks horrendous, right? I wish this was minus x so that it's just a straightforward u substitution, but this is plus x, so there is something funky going on here. So this integrals from UC Berkeley, and it is just terrible if you don't know what you're doing. So again, we're gonna have to go kind of undertow here. Okay, so something suspicious. I don't want to do partial fractions. Let's go ahead and sort of do this. Okay, so let's divide everything by x, which means that we would have to divide everything on top by x squared. x4 plus 1 plus 1 over x. That brings out x squared, so this is 4x cubed minus 1 over x squared. Well, that was easy, right? So now this is just u equals x4 plus 1 over x plus 1. du is exactly what we have for dx, right? So now our answer is just x4 plus 1 over x plus 1. And that's it. Again, this looks suspicious. It's very similar to our derivative, but it doesn't quite fit, right? So, what do? Undertow technique. When something is very sus because this isn't our derivative, it's like an imposter of our derivative. So then we're going to use undertow technique. Alright, divide everything by x. We get 1, 3 x cubed minus 1 of x. Okay, doesn't really relate. Let's do it again. Alright, divide everything by x. Minus 1 over x squared. This is 3x squared. Perfect, this matches. So our answer is just ln of x cubed plus 1 over x plus c. Okay? Huh. Well, I mean, there's a bunch of ln of x's, and I have an x here, so I guess u equals ln of x, and that's like, what? That's going to give me 1 minus 2u. This comes from du, right? And then what do I do with x squared? Plus u, x squared, I mean, here that's e to the u is equal to x, right? So e to the 2u, right? And then we just integrate this. Is this any better? Is this... No. No, this is not any better. So this isn't a straightforward substitution. So what do? What on earth are we going to do? Well, there's something suspicious here. I mean, obviously x squared plus ln of x does not give this derivative, right? But what if we use undertow technique? So if I factor out x, this x squared, x plus ln of x over x, does that give? Let's try it. So deriving this, the derivative of x is ln of x over x. This is 1 plus x squared. Let's see, f prime of g minus f g prime. Does this work? Is it similar? It has to be exactly the same thing as this whole thing, right? Is it the same thing? Is it really? We need to fully check that. X squared plus 1. Yeah, x squared plus 1 minus ln of x. Right? Is that the same thing? I don't think so. I don't think so. So, because of that, we cannot use this u substitution. It does not match. It does not match our du or dx. So we have to do something else. So this u sub does not work. Okay. How about doing it again? 1 minus 2 ln x. x cubed, and now we have 1 plus ln x squared. So now what? Let's try. U is equal to 1 plus ln x over x squared. So now du, with the quotient rule, we have x4, and then let's see, this 1 over x times x squared, that's x, and then minus 2x ln of x. Alright, is that the same thing as this? We can simplify it to check. Oh, wait a minute, there's x on both sides. We could factor that x out. 1 minus 2 ln of x, x cubed. Is that the same thing? Yes, it is! Aha! So now we have our u. So now this is equal to the integral of du of u. This is equal to ln of u. So our answer is ln of u, which is 1 plus ln of x over x squared plus c. Okay? Again, oh my god, the experiment with the derivatives. Experiment with the derivatives. Test it and see if it's correct or not. The amount of times you would come across this in integration B, you have to get comfortable with it. Just experiment, experiment. If it works, if it doesn't work, use a different u sub and see, you know, where it leads to. Okay? Again, the Undertow technique is not very easy to see. A bunch of x squares and a bunch of e to the x's. Again, it's a little suspicious. A little suspicious here. So, if I divide x, I'll end up getting e to the x over x on top, which makes no sense at all. No sense at all. So, we will not be doing that. So, instead of dividing x, what are we going to do? How about dividing e to the x? Let's try that. X squared e to the x plus 1. X squared e to the negative x plus x. Oh. Huh. Close, but not quite, right? This here, we need to have what is the derivative here? Let's just check. We won't use up it, but I just wanna know, what is this? What is this? 2x e to the negative x minus. Okay. So that's that. So I definitely do not have that. Right. That's no. So this will not work. It's going to be disastrous if we keep dividing e to the negative x. Then we both terms here. It's just going to be like it's just going to copy, and it's just going to lead to nowhere. But what about dividing both x and e to the x? Huh. Let's try that. If we divide x e to the x, top and bottom, let's try that. Right. X e to the x with x squared plus e to the x. I'll deal with that later. Right. We have 1 plus 1. But what is this? X squared, and I'm dividing it by x e to the x. X e to the negative x. That's what that is. Okay. But let's handle this junk here. X e to the negative x plus 1. Here I have, let's see, x e to the negative x plus e to the x 1 over x. I'm sorry, not e to the x. The e to the x cancels out. Okay. So I have this. But does that lead to anywhere? No, I don't think so. Maybe not. I don't know. If I divide x again, huh? Plus 1 over x. You might. Okay, this is very hard to see. If you do not know your derivatives, it's super hard to see. You will just come here and retreat, but you're actually at the right path, right? So sometimes you'll deal with that, where you'll soon come to a realization. Wait a minute, I was at the right path the entire time, but it just didn't look right. So again, this looks like nothing. This looks like nothing, but actually, u is equal to e to the negative x plus 1 over x. du is equal to negative e to the negative x minus 1 over x squared. So it's this, but the negative is factored out, right? We're so used to, oh, okay, 1 over x, this has to be negative, right? Well, because we have a negative x here, it can sneak its way like that. So be aware of that. So a negative can be factored out, and they can just take that away from us. So here, this is negative du over u. So the answer is negative ln of e to the negative x plus 1 over x. It's a very, very tricky integral. So be very careful with that. So this looks like a straight up partial fraction. But if you're like me, we want to avoid partial fractions, right? I would want to avoid partial fractions, especially with something like this, like irreducible. Like that's, like I don't want to deal with that. I don't know about you, but I don't want to do advanced partial fractions. So we can do other things. We can use Undertow technique, right? That's one way, but again, that just takes a lot of experiment. So if I divide, well, first of all, I have x, so this is pretty much 1 plus 2 over x, right? But here, this still doesn't give me anything. This numerator doesn't give me anything compared to this. So I'm gonna divide x again, and I'll be dealing with, so I'll get x plus 1 over x, and this would be 1 over x plus 2 over x squared. Is that what I get? Does that compare to anything? No. Very close though. It's close to what I need. But we can do it again. Right? Let's do it again. So dividing x, we get 1 plus 1 over x plus 1 over x squared. So then this is 1 over x squared, 2 over x cubed. Huh. But it doesn't have the negative. Oh wait, but both of them needs a negative. So the negative was factored out. So we could just, so this is actually good. We can actually now u sub this. Right, and again the du is the negative version of this. Right? So it's just negative du over u. So it's a negative ln of u, which is 1 plus 1 over x plus 1 over x squared. Oh god. it has a mixture of x's and e to the x's. So, of course, this has to be dealing with Undertow here. So, let's go ahead. I want to simplify this. E to the x, 1 minus 1 over x. Right. Very suspicious. We might probably want to do Undertow technique. So, let's go ahead and do that. Divide everything by x. Oh, I'm sorry. Undertow x out of this. So, so dividing x would be 1 over x minus 1 over x squared, and then 1 plus e to the x over x. Huh. E to the x over x. This looks like product rule, right? If we see this as product rule, du is equal to e to the x 1 over x plus e to the x minus 1 over x squared, which is exactly what we have here. So this is just, again, we already know du over u. This is just ln of 1 plus e to the x over x plus c. Our last integral for this technique, I think this integral was from brilliant.org, I think. But this looks chaotic, right? First of all, we have a bunch of x's, so let's go ahead and divide x, right? Just looking at this looks very suspicious. So, Undertow technique, probably. X plus 1 minus 1 over x. And we have x squared plus x ln of x plus 1. Okay. Huh. Maybe we should divide x again. Right, because it looks very similar to our bottom, right? The numerator looks similar to the derivative of our denominator. So whenever that's kind of sus like that, we use Undertow. So divide x, we get 1 plus 1 over x minus 1 over x squared, x plus ln of x plus 1 over x. That looks correct. That seems to be right. The top is the derivative of our bottom. Alright. So now this is ln of x plus ln of x plus 1 over x plus c. And there you go. And that's the Undertow technique. Very difficult to spot. So you just have to be very comfortable with this, of how it works. It just takes a lot of experience. So it's very sneaky, very tricky. If there's some awkward integrals that looks like this, try to use Undertow technique. Okay? And don't forget to experiment with derivatives. That's also very important. Alright. So thank you guys so much for watching. I hope this is very helpful. And I'll see you guys in the next section.